How's it going, everybody? Today, I want to talk about the use of isokinetics in ankle sprain rehab. First up, this clip shows the standard way that most clinicians are strengthening ankles. And if you could see me, you'd see that I'm throwing up finger quotes when I said strengthening. Because you're going to see in today's video that this is far inferior to an isokinetic machine. First, we need to examine isokinetic versus isotonic versus banded resistance in exercise. So first, we're going to look at a graph of force versus range of motion. And on the graph, the higher the line goes in the vertical direction, the more force output the muscle creates. The x-axis, or the left and right direction, indicates how bent or straight the joint is. And in this example, we're going to be using the quadriceps, with the left side of the graph with the knee all the way bent, and the right side with the knee all the way straight. If we first look at the green line, that represents an isokinetic curve. And the advantage of isokinetics is that the machine is able to adapt its resistance to match the patient's output. So you can see that when the knee is fully bent, the quad is pretty weak, but as the knee reaches mid-range around 70 degrees, it hits its peak force output. But then as the knee begins to straighten out, the force output drops. And this is an example of an ascending-descending curve. Now let's compare that to the red line, and this is an isotonic exercise, and that's a traditional exercise like using a dumbbell, a barbell, or a weight machine. And in isotonics, the load is fixed, so if I put 100 pounds on my knee extension machine, it's always 100 pounds. So that's why the red line is flat through the entire range of motion. But here's the problem. I have to pick a weight that's light enough that I can still move it through my weakest point in the motion. So you can see here just how much the muscle is being robbed of its ability to be loaded adequately throughout the majority of the motion. So now let's go one step farther, and I'm going to add a blue line, and that represents a banded resistance. And this shows that at the start of the motion, I have minimal resistance, and it increases as the band is being stretched through the range. And I know that I'm oversimplifying it because most bands don't increase in a linear fashion, but this still gets the point across. And again, we have to set that maximum load to the weakest point in the range of motion in order to get through the entire range. Now let's look at a graph that looks at these different exercise modes and how it affects the muscle's capacity through the range. So now on the graph, the higher you go in the vertical y-axis direction, that's the more that the muscle is being challenged. And 100% is the most output the muscle is capable of putting out. Again, we're going to set the x-axis to represent the range of motion. And you can see that the green isokinetic line is at 100% across the entire range. And that's because the machines are able to adapt their resistance to match the output. But if we look at the red line, it dips down in the middle of the range. And that's due to the quadriceps being weak at the ends of the range of motion, but strongest in the middle. So the muscle's not being challenged throughout most of its range, because we have to set that maximum load to accommodate for the weakest points. And now, if I throw that blue line back on the screen representing the band, you can see that it's not challenging the muscle at all at the start of the motion, and it only reaches maximum capacity as it's being elongated. And again, this shows just how much traditional isotonic and banded resistance just can't compete with isokinetics. So now let's look at an actual ankle everter graph, because the ankle doesn't follow that ascending-descending curve like the quad does. If we look at the graph on the right side, that's the eccentric ankle everters. And the red line is the healthy left ankle, and the blue line is the injured right ankle. And I'm placing a vertical line on the screen just to show you the neutral position of the ankle. So everything on the right side of the line is the ankle when it's inverted, and that corresponds to when the everters are lengthened. And you can see that it's also when the muscles are hitting their maximum torque output. Everything on the left side of that neutral line is with the ankle in its everted position. So for the everters, that's when they're in their shortened position. And it also shows that that's where they're their weakest. And I'm going to put a couple horizontal lines on the screen, just showing the difference in strength in that injured ankle between the strongest and weakest points. So when the muscles lengthened, they were able to hit 13 foot-pounds. But when the muscle was shortened, they're only able to hit 6 foot-pounds. So it's half the amount. And now let's bring it full circle, and I'm going to put a line on here showing banded resistance. And it starts out when the muscle is lengthened with little to no resistance, and it gets more resistance as that band is stretched out. But unfortunately, it's in the opposite direction of what we would need. So you can see that we set the band's maximal resistance to the muscles at its absolute weakest point. And you can see that here again in the video. The band has minimal resistance when the muscle's in its elongated strongest position, and it has maximum resistance with the muscle in its shortened weakest position. And let's quickly look at the resistance that I picked for this video. I chose the blue TheraBand CLX because it's a commonly used resistance in ankle rehab. And I measured the amount of elongation when I did the exercise. The band's resting length was 32 inches and it ended up at 38 inches. So that's about 20% elongation. On the graph here, we can see that that gives me about 3 pounds of load. And if we go back to the patient's actual test, this is well below the load we need to challenge this muscle enough to get it stronger. Now, it's a good starting point, but the patient's going to quickly need more load in order to normalize their strength. And we could pick a heavier band or just elongate the band even more, but it doesn't change the fact that we're loading our band's maximal resistance at the ankle's weakest point. And I think that resistance bands are a great way to load the patient for their home exercise program. But let's check out what it looks like on the Humac Norm Isokinetic system. In this clip, I'm exercising my left ankle everters. I'm resisting against the machine during the eccentric portion, or more simply put, I'm pushing to the left while the machine is moving my ankle to the right. And I'm relaxing during the concentric portion, which allows the machine to place me in the starting position for the next eccentric contraction. And this technique is typical for the early to mid phase of rehab. And I also have the speed set in this video to 20 degrees per second. And over the course of rehab over the next few weeks, I'm going to increase the speeds, but I'm also going to have the patient perform both the eccentric and concentric portions of contraction. And if we zoom in on the screen showing the biofeedback, you can see that when my ankle everters are shortened, they're producing minimal torque. But as they're elongated eccentrically, the torque increases all the way to end range. And this natural increase in load as the muscle is being lengthened is the exact opposite of what we get with the band. So this video shows that if you have an isokinetic machine and you're not using it for your ankle sprain rehab, you're really missing out on a major use of the equipment. And if you don't have a machine and you're interested in adding the Humac Norm Isokinetic system, visit humacnorm.com. If you've recently sprained your ankle and you need advanced rehab, or you need to test the strength of your ankles, visit proactiveathleticperformance.com and send me a message. Remember, if you're not testing, then you're just guessing.